Okay, I want to do two more problems in the notes here to finish up the section 4.1, excuse me. In this section, I wanted to analyze each polynomial function using steps 1 through 8 on page 193. Let's do problem 84 first, and then we'll do problem 90 second. Okay, so in problem 84, I've got f of x equals x minus 1 times x plus 3 squared. On page 193, you'll see the 8 steps in order to graph a function, and so all this is information that you can see in the book. And so I'll have us refer back to that on occasion. Step 1 is to determine the end behavior of the graph of the function. Okay, so I've got x squared times x, which is x cubed. There's a 1 in front of x cubed. So I know that the graph is going to fall down on the left and up on the right. Okay, similar to what I would see with y equal x cubed. It's going to go down on the left and up on the right. Okay, step 2 is to find the x and y intercepts for the graph. To get the x-intercepts, I would need to let y be 0, and to get the y-intercepts, I need to let x be 0. When I let y be 0, y and f of x mean the same thing. X minus 1 times x plus 3 squared equals 0, means that x is 1 and x is negative 3. The y-intercepts, when I calculate f of 0, negative 1 times 3 squared is negative 9. Okay. So step 3 is to determine the zeros of the function and their multiplicity. And it says afterwards, use this information to determine whether the graph crosses or touches the x-axis at each x-intercept. Okay, so we're going to have we're going to have a 0 at 1, and that's going to multiplicity of 1. That means it's going to cross at x equals 1, and we're going to have a 0 at negative 3. It's going to multiplicity of 2. And that means it's going to touch the x-axis at x equals negative 3. The fact that it touches at x equals negative 3 means that it's going to kind of resemble y equal x squared there. Okay. Step 4, I've got, when we hold off on step 4, we'll do that in step 6. Step 5, approximate the turning points of the graph for f of x. Okay, so I've got x times x squared, and there's a 1 in front of x squared, 1 in front of x cubed. So with there being a 1 in front of x cubed, I know that there's going to be at most 2 turning points. Okay, let's graph the function. Okay, so if I go to y equals, and I've already got this typed in, and then I hit graph, and the window that I used here is negative 5 to 5, and then negative 20 to 30. Okay, using an increment of 1. If I hit second and trace, and then let's get the minimum first. Okay, I'm going to have a minimum at negative 3.3, negative 0.33. Okay, and we get the maximum now. Oops. Okay. So I hit enter there. There's a maximum at -3. Okay. -3. And so, I found the two mins and maxes, and that allows me to graph the function. And I can plot some more points on this graph, like if x is 1, I get 0. Okay, and if x is 0, I get -1 times 3 squared is 9. So 0, -9 is on the graph. Now at 0.33, I don't know if you saw it or not, the -0.33, the y value is -9.48. Okay, and that would be a min, since -9.48 is slightly less than -9. At 2, 2 minus 1 is 1, times 5 squared is 25. Okay, there's 225, and there's -4. -4 minus 1 is -5. -4 plus 3 squared is -1 squared. So -5. Oops, right here. Okay, and so I just quickly, plotted some additional points there on this graph. So that answers question 4 and question 6. In order to, I drew this by hand. Step 7 is to state the domain and range of f. Well, the domain of f is all real numbers, and the range of f is also all real numbers. Okay, so we can see that on the x-axis, the curve is going to head upward and downward in both directions. On the y-axis, the curve is going to do the same thing, head upward and downward on both directions. Step 8 says use the graph to determine where the function is increasing and where the function is decreasing. Okay, it's all about x. Okay, to state where the function is increasing or decreasing. So it's increasing anywhere that we get up to -3, and then at -0.33, I'm still increasing. Okay, so at -infinity to -3 and -0.33 to infinity, I'm increasing. Now I'm decreasing from -3 to 0.33 because the slope of the tangent line there is a negative slope. Okay, so that's a quick sketch of the graph of problem 84. Okay, let's do problem 90 next. Problem 90. Oops. Okay, so I'm using these 8 steps to graph f of x equals x squared times x minus 3 times x plus 4. Okay. And okay, so step 1, here it is. Here's the function that we're given. Step 1 is to determine the end behavior of the graph. Okay, so I've got x squared times x. That's going to give me x to the 4th. I've got a 1 in front of x to the 4th. So I know that with that even degree and a 1 being there, that the graph is going to open up on both ends. Okay. Step 2 is to find the x and y intercepts of the graph. Well, to get the x-intercepts, I need to let y be 0. Y and f of x mean the same thing. And to get the y-intercepts, I need to let x be 0. When x is 0, I'm going to have 0 times anything is 0. So 0, 0 is going to be one of the intercepts. To find the x-intercepts, I conveniently already have this in factored form. And so x squared equals 0, x minus 3 equals 0, and x plus 4 equals 0. X equals 0, x equals 3, and x equals negative 4 are the three intercepts there. Okay, at problem 3, determine the zeros of the function and their multiplicities. Use this information to determine whether the graph crosses or touches the x-axis at each x-intercept. Okay, so at 0, I've got 0 has a multiplicity of 2. That means it's going to touch the x-axis at x equals 2. And at 3, I've got a multiplicity of 1. And at negative 4, I've also got a multiplicity of 1. It's going to cross the x-axis at those two numbers there. Okay. We'll skip step 4 for now, and step 5 is to approximate the turning points of the graph, and so I've got a degree 4 polynomial, okay, with this being x squared times x, resembles x to the 4th, and knowing that that has a 1 in front of x to the 4th means I'm going to open up on both ends, and there's going to be 3 turns at most. Okay, there's always going to be n minus 1 turns. Okay, so from the graph, I can see where the curve is going to cross there. So or touch. X equals negative 5 to 5, negative 50 to 50, negative 50 to 20. Sorry. Okay, and then we'll graph. Oops, looks like we've got the y there. Oops. When we go negative 60. There we go. Okay, and so there's my graph. Going negative 5 to 5, and then negative 60 to 20. Okay, and so I've got to find the min. Let's get the min first. Okay, the two mins. Okay, so negative 2.85, and then negative 54.64. It's right there. Okay, let's get this one next. Okay. 2.1 and then negative 24.2. 1. Okay. So, and then let's get the max next. Let's see, so something really close to 0, and then something really close to 0. We got, for all practical purposes, 0, 0. And of course, I can see that from the function there. If I let f be 0, I get 0 in return. Okay, so 0, 0 is going to be an absolute max. I suppose that at x equals -4 and x equals 3, I can use those 2 points. So 0, -4, and 3. And then here's 2.1, -24.21, and then -2.8, -54.56. I've got 2 more points plotted there, so -2, -40. Let me check that. So -2, so I get 4 times 5 is 10, and then times -10, and then -2 plus 4 is 2. 4 times 5 is 20, and then times 2 is -40. Okay, and then 1. Let's see here. 1 times -2 is -2, times 5 is -10. Okay, 1 -10 is right there. The domain and the range of f, we get that next. So the domain of f is me all real numbers. The curve heads upward on both directions there, both sides there. The range of f, okay, if we're at, in terms of the y-axis, -54.64 to infinity would be the range. And I want to include -54.64, since I'm including that point there. Were we increasing or decreasing on the graph? Well, let's see here. So we're increasing from -2.85 and negative infinity to -2.85, and then 0 to 2.1, okay, is where I'm decreasing. Sorry, I said increasing. Negative infinity to -2.85, and then 0 to 2.1 is where I'm decreasing. So if I draw a tangent line to the graph, the tangent line is going to have a negative slope to it anywhere. And then I'm going to be increasing from -2.85 to 0, okay, and then 2.1 to infinity. Okay, and if I draw a tangent line there, it's going to have a positive slope, I can see. Okay, so that's all we have time for here in this video. The problems are on page 197, and be sure to look at the homework there for me.